Welcome guys. In this section, let us understand Selenium Grid. Okay, so first of all, what is this grid about? So Selenium Grid is one of the smart proxy server that makes it easy to run your tests in parallel on multiple machines. Okay, so in the last few sections, we already saw how to run tests parallelly using testng, right? So from your testng XML, if you set parallel attribute, then test will start running in parallelly. That's not new to us, but this is something new, running these tests in multiple machines. So there is one disadvantage earlier. When we ran 3 tests in parallelly, all the 3 tests triggered in the same machine, right? That is one way, I agree. But what if you have 15 test cases and if you trigger all them parallelly, and what if all start on the same machine? Okay, your machine will run out of memory, right? So when 15 Chrome browsers open at a time to execute, so then obviously your system will eat up resources and tests will start failing because of slowness in your system. So instead, those 15 test cases, how about distributing them into multiple machines, like running 3 per machine? How does that sound? Okay, so that way 3 per machine, your system can still handle it. Your server can happily run all the 3 without any issues parallelly. But you see, all the 5 machines are executed at a time, so that 15 test cases, the execution time is same when you run everything in parallel on one single machine. But when you run in single machine, you may run into a lot of issues. But here we are distributing them into different machines. So that way you will not see any flaky errors, and your system performance also will be on the speed mode because you are running 2-3 browsers. So that's where Selenium Grid comes into picture. It will help you to run your tests in multiple machines. So that means you will control your execution from one single machine only. Okay, so you will just say run this test, but your machine will distribute the execution. So now when you run your testng XML file, let's say there are 10 tests inside that. So from your Eclipse, you will just run that test XML file. But once the execution started, the Selenium Grid will take over those 10 test case requests and it will distribute to different machines to execute, right? That's where Grid comes into picture. So first let's understand how that is possible. So how does Grid works internally to distribute your execution from your local system to different machines? And it should also report us the output, right? Whether a test or pass, it should consolidate it again, output from different machines, and it should report in your Eclipse console. How does all that happen? That's the magic of Selenium Grid. Looks exciting, right? Let's try to understand the internal architecture of this grid, and then we'll set up the whole infrastructure, and I'll show you live here on how to trigger that in multiple machines. Okay, so this is what they have redesigned architecture in latest versions. But overall, your grid looks something like this on high level. Okay, there is one centralized execution system. You can call it as a hub, but this hub consists of all these internal architecture components. Okay, so when you go deep dive into this main execution system, there are different components we have here, which I will talk about that soon. But overall, from high level, the hub could be in your local system, like where you are running and writing your Selenium code, so that you can treat it as a hub. You can start this execution system in your local machine, and when you run your test will first reach to this hub, and then this execution system hub will decide on how to distribute tests into different machines. So here in Grid terminology, different physical machines, we call them as a nodes. So this is one physical machine, and this is one physical machine, and this is one physical machine. So in this architecture, to your grid infrastructure, there are 3 different physical machines are connected. Nothing but 3 nodes are connected. Okay, so let's say you have Firefox installed in one system, Chrome installed in one system, Opera in another system. So when you run your test, and if your test demands Chrome, then it will divert traffic to this physical machine. Okay, at runtime, this grid execution system can read your script properties and decide which can do the right job. Okay, so if it demands Firefox, it will send here. If it, let's say, in all the three physical machines there is Chrome installed and your tests also asking to run in Chrome, at that time it will load balance. That means if you have 10 tests and if already 5 and 5 are assigned to this, and if you ask another test to run, then it will see that already 5 assigned, it will divert other traffic to another physical machine. So like this it will balance, like if you have 5 test cases, 2 2 2 2 2 1, like that. So everything this execution system can take care. At runtime, it will read your script properties to know what browser you want to run and what operating system you want to run. Now let's say one of your machine is Mac here and one is Windows. And if your script demands to run on Mac, then it will divert your test to run in this Mac machine. It will not send request to these two machines. So that's the knowledge your grid have. Okay, so now let's deep dive into see what is this green infrastructure consists of. Overall, this whole constitutes a hub. We call it as a hub, and there are a lot of components inside the hub. So in earlier versions, they didn't expose all these components. So recently they started, Selenium Grid have officially shown up in their documentation that what's going on internally in this hub infrastructure, so that people can troubleshoot the things. Now first, you can see that client, that means our Selenium raw code which you write in Eclipse. When you run that, when you run your test.ng XML file, then you are making a request to execute your test cases. So client is nothing but your local system, Selenium Java, which sends a request. So here we are executing, and when you run your test, first request will go to this router. So there is one processor internally in this grid. You can call it as a processor or component. So the request, first router will receive your request, and then it will immediately ask a distributor to create a new session and assign that it to the one physical machine. So all your requests first router only will receive. If it is first time request, if router is receiving brand new request for first time, it does not know which physical machine it has to route. Okay, so basically router job here is to route to the physical machines, but first time it don't know to which physical machine it want to route. So what it does is it request to distributor. So this distributor is a guy who will read your script properties and understand what is the right physical machine for you to execute. Okay, so it will check what operating system you are expecting, and it will see what physical node machines it have to send a request, or what browsers you are executing, or if it is a common Windows and Chrome, then it will see like load balancing, like what physical machines are already occupied with test and what else I have to assign. So like that, distributor will some work, and finally what distributor does is it will send a request to node to execute that particular your client code. That means a physical machine. So once it sends session to one physical machine to execute, at the same time what distributor does is it will send information to session map also. It will tell you that hey, I received one session, this is the session ID. So whenever you create a new session, every time your new session will have an ID. Okay, so when I say session here, that means a session what you send from your client, that means from your local Eclipse. When you run your test.ng code or Selenium code, one session is created. So that session information, what does distributor do is it will give it to session map. So this session map guy will store that session information, and distributor will also give the information about on which physical machine I assigned this session. Okay, now you are running some Google homepage automation, that is one session, right? That's one test case. For that test case, you assigned one physical machine for that. That physical machine IP address also, that information it will give to session map. So duty of session map here is to simply create one map which consists of what test it is executing and in what physical machine it is executing. That information it will store. Okay, the test which is executing is nothing but session ID, and in the physical machine which it is executing, nothing but node URI. That information it will store here. Now, so client, when it is running the test, at a time it won't send entire code. Let's say in your Java file, there is 10 lines of Selenium code, right? First line of Selenium code will get a request, and then all this distributor will see and will assign physical machine. Next, subsequently, if you are getting the code from the same session, from same test, now what does router do is, again it will not ask distributor to figure out which physical machine, because distributor is already figured out earlier for that test where to execute, which machine it execute. Okay, that information is already there in session map, right? So for subsequent request, what does router do is, it will simply talk to session map, hey, I got another session, just check if it is already existing session. Oh yeah, it's already existing test. And what is the physical machine? Okay, this is the IP address. Okay, let me route it. So it will directly route it to that particular physical machine. Okay, only for first time it will take distributor help, and distributor does the work of assigning and giving, updating to session map about properties and values. So thereafter our router will take care for every subsequent request from same test to assign back to the physical machine. So that's how internally your grid is designed. Okay, so now when you look at on high level, you know that hub, it constitutes basically all these components, and then at the end you see the node, these are the physical machines, it will assign it to the nodes. So now from the next lecture, let's actually create one hub, and let's create some nodes which are physical machines, and we will register them, and we will see how the real-time execution happens by running in the different machines. Okay, theoretically this is the concept. People try to ask you in the interviews about explain grid architecture, then you can nicely create this diagram and explain what each and every component does here. But in practical, story will be different. It's very easy that you can simply make this hub and server nodes up, and you can connect them, and you can just distribute your test, which step by step we will see from the next lecture with the infrastructure setup instructions. Okay, welcome back. Thank you. So in this lecture, let's see how to set up Selenium Grid in our local system. So there are different ways you can set up the Selenium Grid. So if you go to their official documentation, so let's see what they are saying about setting up the grid. So several components compose a Selenium Grid, right? We know that. Okay, so if you check out our architectural, so there we have clearly discussed that these are the different components. So all these components together constitutes a grid, right? So depending upon your needs, you can start each one of them on its own or a few at same time. So now when you want to set up this grid architecture in your local system to schedule your tests in different nodes, there are multiple ways to do that. One is you need to start your router service, session map component, distributor, all this separately you can start them and then work on it. Okay, that's what they are saying. You can start each one of them on its own, or there is another way also which we can do by saving time. So all these you can start together also as a hub. Okay, so now if you scroll down, so they are saying that you can start together or same time by using a grid role. So there are different grid roles here. One is standalone role, and one is hub node, and one is distributed role. Okay, so let's try to understand what is difference between all these three. Now, if you want to start your grid in a distributed mode, that means each component needs to be started on its own. Now, if you want to set up in your local system in this distributed, then you have to start this session queue and router, all the components what you see here, you have to start step by step separately by giving the related commands. That's how you do in the distributed mode. But there is another mode which is very friendly called hub and node. Okay, so this mode is there from the previous Selenium versions also. It's very suitable for small and middle sized grids. So most of the companies rely on this hub and node kind of setup. So basically what do you do here? So here you simply start the hub. Okay, there is one command which will trigger you to start the hub. So once you start the hub, automatically the components inside this hub will start. Okay, you really need not give again separate commands to start each and every component here, like router, session map, distributor. Everything will get triggered, will get start automatically if you start hub, which is a global one for this. Now in their documentation you can read that hub is the union of the following components. So it is a set of router which will take your incoming request from your Selenium test, distributor which decides which node it has to execute, session map which can store the session ID and also the node physical machine address mapping related, and new session queue. We did not talk about this, right? So where does this come? New session queue is something like when you initiate multiple sessions from your Eclipse Selenium, so distributor can solve only one session at a time. So all the remaining sessions which are waiting for distributor to check, they will go in the queue. So this comes between distributor and router. There will be another component. So that component will actually store all the new sessions in a queue, so that distributor one by one will retrieve the item from the session queue and it resolve to check to which physical machine it has to provide. Okay, so if you are sending only one request, there is no scope of session queue here. But if you send multiple requests, multiple test files execution, so there will be one session queue where your sessions first will sit there and wait for a distributor to pick it up. So that also you have to separately start as a component. And event bus. So event bus is a virtual here. So all this communication, whatever you are seeing in the arrows, this is all they are communicating internally, right? So they are making communication through event bus channel here. So to enable this communication, there is another component that also you have to start. So all this separately you have to start if you choose to set up Selenium Grid in your system on distributed mode. But if you want to choose hub and node way to set up, then simply start the hub with one single command here, and that automatically sets up all these components for you, which will be super cool. So in this course, I am going to show setting up the grid using this hub and node, which will be very simple and which is mostly used across than distributed mode. Okay, now let's get started. So first, let's treat this local system where I am showing you all this is my hub. So here where I'll start the hub, and if I start hub in this my local system, all these components also will get started in the same system. Okay, but before you set up all these hub and nodes, first you need to download one separate Selenium jar which supports this Selenium Grid architecture. So if you go to their official documentation here, so go to downloads, or you can just search Selenium download in Google, which will take you to this page. So you see that for grid, there is one separate jar file you have, which you have to download, or you can go to Maven and ask for Selenium server dependencies. It's up to you. So let's create one small project and we'll deploy these jars and we'll get started. So first download the Selenium server jar in your local system. This will just come as a one single jar. That's it. Okay. So once you download this jar, so make sure you create one folder called grid or any other and store that Selenium jar inside it. So reason why I'm telling you this, because so later when you run your WebDriver tests or Firefox tests, you know that there should be one Chrome driver file and Gecko driver to run Firefox and Edge driver file to run in Internet Explorer. So we have different drivers, right? So these drivers should be in the same path where your Selenium server is downloaded. Okay, so that's why what I suggest you, so start by downloading the Selenium server and again download all the browser drivers. Now if you want to execute in Chrome, then you know that you need Chrome driver to download that, right? To execute in Chrome. Go ahead and simply say Chrome driver download and get it based upon your local Chrome browser version, right? And similarly get Gecko driver also. So all of them just place in the one folder. Now I already did. Let me show you. I think I created one folder called grid. Yeah, here you go. Let me pull up that for you. So yeah, so I created a folder and here I downloaded the Selenium server grid jar and then Chrome driver, Gecko driver. So by now you are already familiar with these two because these helps us to execute in Chrome and Firefox driver. So once you have that in one folder, now go ahead and your command prompt or terminal. So if it's in Windows, we say it as a terminal. Sorry, Windows is command prompt and Mac is terminal. So go to the folder where you have all these files. Okay, so right now I am actually in users. So here let me go to grid. Okay, so once you are on the path where your files are located, so right now I came to the grid directory. So from here you have to first start your hub. You know, if I say start hub, that means we are going to start all these components, right? Now to start the hub, I have given some step-by-step instructions here. So we downloaded all these drivers located in the same path. Now to start the hub, you need to give Java -jar, tell what is your jar name, space hub. That's it. This will start you the hub, which eventually start all these components. Okay, so let me show you. So you can have that Word document handy, which you can download from this lecture. Java-jar. So here you have to provide your jar name. So that means this is your jar, right? So you can copy that complete name exactly how it is and you need to paste it here. So basically we are asking to invoke that jar file. Simple. So when you give this command, that jar file will be invoked, but we want to invoke that jar file as a hub so that hub will start, hub processor will get start in your system. So for this jar file, we are sending hub as an argument. So this argument will be sent to this jar file and internally the processing will be done and which eventually starts the hub and the related components. That's it. So after you give this, just press an enter and you can see that some logs generating, but overall you can see that sockets ready, event bus ready, and your Selenium hub is started. Okay, cool. So that means now 50% job is already done, guys. So this is set up in your system. Now, if you want to check the status of your hub, there is one way where you can check. So if you go to the localhost :4444, right? If you give this, then it will give the status of your running hub. Okay. So if you are wondering how would I know that my grid hub started at this port number, simply read your log. Here itself it's telling you that we started Selenium hub at this port number 4444. Okay. So as it is in your local system, instead of giving IP, you can simply pass this localhost 4444 port number and here you will see the details. So now they are saying that you have a grid setup by registering the hub, which is great, but you don't have any registered nodes. So that means you have a hub ready, but you have to attach physical machines to this hub, right? So when distributor is ready to assign the tests to your different physical node machines, it has to know what are those nodes, right? So that means you have to create nodes and register to your hub. Then hub is aware that, okay, these are the currently these many nodes I have. When tests are received, then I will distribute to these nodes, right? Without registering your node to this hub, your hub will never know what nodes it has to delegate. That's common sense, right? So now our goal is to start a node and register to your hub, and then hub will start listening to that node, and whenever you receive any request, then it will assign it to that node physical machine. And you know what? Hub and node can be your local system also. So in the same system you started hub, and node also you can start in the same system. So that means when hub receives request, then it will assign to the node, which is again your machine only. So test will start getting executed in your machine again, right? So like that, hub and node can be in the same machine also. A hub can act also node to execute test. But ideally in real time, nodes are nothing but some different physical machines you will take for running your automation test. Okay. So in this course, I will tell you both ways. First, I will tell you how to start node in this local system only. So that way hub and node both will be in my system. In next lecture, I will take another physical machine and I'll start there and I will register that physical machine node to this hub, and we can say how tests are executed in another physical machine. So we'll see different combinations. Don't worry. Now, to start the node again, go back to the Word document. So there are two ways: starting in your machine, starting in different machine. So now to start in your same machine, again from that folder where you have your jars, you can again call that same jar file, just like how we called earlier for hub. But this time send argument as a node. So that means it will know that it has to invoke as a node. And you need to give a flag called detect drivers. So if you remember, we have a driver sitting in your folder. So we are asking to detect these because now node is nothing but a physical machine. So this physical machine is ready to run your test. When you ask to run test in Chrome, it will search for where is Chrome browser, Chrome driver, right? So when you have it in the same folder and you ask to detect, so later when this node receives a request of running in Chrome browser, it will use this existing Chrome driver. Okay. When it receives a Firefox request, then it will use the existing Gecko. So that knowledge it will have only when you say detect drivers in the path with true. Okay. So hub is already started here. Don't disturb this. Okay. You won't have again terminal to give another command. So keep in that way and you open another tab here. This is in Mac, but in Windows just open another command prompt window, and there you start giving the another commands. It's simple, guys. So no matter it's the Mac or Windows, process is all same, but just a different terminologies. There you will see a screen with a black in Windows. You can still make it white also. I'm just telling you, there's no difference. Operating system independent. That is the beauty of Selenium, right? No matter you run in Linux, Windows or Mac, code will be same, steps will be same. No difference. Okay. So now let's start java-jar, and this time again give the name of the jar. So in my case it is 4.1.2.jar. So I want to now execute this as a node, and I also want to detect drivers to set to true so that it will know what drivers it have in the folder. Okay. So give this command. So basically here we are starting the node in the same hub machine. Okay. So you can read the description here. It's saying that it started node successfully. Node is added. So if you want to check whether node is successfully added, now go back to your status. I told you right here where you can check the status of grid, and here you go. So you see that one node is added, and it is saying that it have ability of running 10 Chrome browsers, 10 Firefox and 1 Safari. As it is a Mac machine, you are seeing a Safari. If it's in Windows, you might not see Safari here, right? So your Selenium Grid detected this node have a capability of running in different browsers, and it can start up to 10 tests at a time in this node, right? So that means it can start 10 Chrome, 10 Firefox and 1 in Safari. That's the capacity of your node, right? And your node is listening at this port 5555. Okay. So that information you will have it here. You can see that started Selenium node at this port 5555. Your hub is listening at 4444. And now when you come back to your hub logs, here you will see that a new log is added saying added node, health check every 120 seconds. So every 2 minutes it will make a ping to the node and see if it is still active to delegate, right? So once you added node here, come back to your hub terminal and you will see that status updated, that one node is added. So that means now if you go back to your diagram, so one node we attached, but technically that node and hub, everything in same machine. That doesn't matter for these people, okay? So as long as you set up grid, if you assign node, if it's a same machine or a different machine, it will just assign the request and your test will execute. Okay, so good. Now in the next lecture, I will switch to the different machine, and there let's go ahead and set up the node, and we will register that node to the hub which is present in this local system. It will be interesting, guys. Just follow me. Okay. All right, guys. So now I have opened another physical machine and I connected to that machine through TeamViewer. Okay. So right now our actual hub is in this machine 1, where we have already started one node and one hub. So now I am going to start another node in different machine. Okay. You can see that we have connected to that machine through TeamViewer. So you have to repeat some things in the node machine before you start the node. So if you go back to Word document, let me show you. See, in the node machine also, you have to download again Selenium server and download all the browser drivers and place in the same path where your Selenium server is located. So you have to repeat this step in all the machines where those machines are acting as node, because those machines are ultimately responsible to execute your test cases, right? So from hub, you are delegating the access. Now to run these test cases in these different machines, so in that machine, Selenium code should be there, right? Without having Selenium code, how that a machine can know how to execute? In that machine, Chrome browser should be there. Chrome driver should be there. Okay, now most of the students make a mistake that they select a machine to execute, but they don't install Chrome browser in it. And now they want execute test in Chrome browser. So if you don't have browser at all in that machine, how does test execute there? Now in your local system, if you don't have Chrome, will it execute? Similarly there also, right? So all the setup what required for automation, you should first prepare in the machine what you selected to run your Selenium tests. Now, so here the only setup what we need is download that Selenium server jar and download the driver files and make sure you put it any folder. It's up to you what folder you call. So similarly what I did here, I went to the grid folder. Let me show you. So I'll close this. Right. So just like how I have created in the hub machine, similarly in my node machine also, I created one folder like this, and here for now I installed Selenium server jar and just a Chrome driver, assuming that Firefox will not run in this machine. So if that is the case, if your test receives the request of Firefox, then your grid won't allocate that Firefox related request to this machine. Okay, to show you that I did that intentionally, did not have Firefox. And later I will show a test running in Firefox, but that won't execute in this node machine. Okay, right, these two I installed. Great. So in grid folder, I created one folder, and once you have that, now go to the same folder path in your command prompt here, and then you have to just give the same node command what you gave earlier in the hub machine to start. Same thing we'll do here also. Java -jar, and you have to give the name of your jar, which is Selenium -server. See, this jar name will be different based upon what you download at that particular moment. Now 4.1.2 is version. In your case, it could be 4.9.5, anything. Just exactly get the same name. And now here you are starting the node, right? So then you have to give node and tell detect drivers true. So that way it will know that where Chrome driver is present. But this is just not enough. So we gave the same command earlier in our local hub. There it worked, because here hub and node are in the same machine, right? So here node started at 5555, and if it want any help from hub, it will simply make a call to 4444 port, because in the same machine hub is started, so it's easy. But here this is the entirely different machine. If you want to ping a hub, that's not present in this machine at all. So if you make 4444 call, that will make a call to your node machine port where hub is not there. So what do you want to do? So basically you need to register your node to your hub machine. Okay, how to do that? So for that, there are some internet transfer protocols you have to use. Just type this publish events. So there are events exposed by your hub when it started initially for first time. Let's see that. You can see that TCP 4442 and 4443, XPub, XSUB. These are the transfer protocols. Okay. So here where you will have all the information about your hub, right? So now you should make sure that your node is connecting to these binding socket protocols. Okay, so these sockets are at 4442 port, 4443 port. Now let's see how we can connect to those ports from your external node machine. It's simple, guys. You have to start like this, TCP. So what is TCP? You can just Google very quick to understand. So that way you know that I'm not typing something rocket science. Transmission control protocol. So that means it is used on top of IP to ensure reliable transmission. So that means from our another physical machine, we are making an information transfer from node machine to hub machine. So to make that happen, you have to start with TCP so that this protocol can transfer and ping the machine where you are looking for. So you have to give the IP address of your hub first. That's where you can reach there. Okay. So you can get the IP address of your hub by, if you go to hub, you will see that this is where your hub is started, right? And this is the IP address 39. What you are seeing is 139. Okay. So first you have to reach this IP address. Once you reach this, that means officially first you will be inside this hub machine. From there, you have to reach these ports XPub and XUB, which are sitting at 4442 and 4443. Okay. So first let's reach hub IP address dot. Yeah, this is the IP address. Now here you have to reach 4442 port, right? So there are two events here, publish events and subscribe events. Now if you check out your node again, see XPub stands for publishing event. So publishing event is 4442. Yes, we are making a ping to that, asking to register. So similarly, we have to make a ping to 4443 also. So that this is on the subscribing event. So just like how you have written like this, now hyphen hyphen subscribe, because we are now making call to another event, events. And now give the IP address again to your machine, but this time you will target what? 4443, right? So now if anybody asks you to explain this, it's very simple, guys. I'm just explaining one more final time that there are two events, two sockets basically, publishing event and subscribing event. So you have to ping to these sockets of your hub, then node will be successfully registered, right? So to make that ping, now the publishing event is listening at 4442 port, but that 4442 port is not in your external node machine, right? This is hub is in different machine. So that's why we are making a call TCP colon, give a IP address where your hub is sitting. You can get the hub IP address here when your node started, colon 4442. So you are making a call to that publishing event. So that's why you have written like this, hyphen hyphen publish events. And next you have to make a call to subscribe events also. SUB stands for subscribe. So that's why you have written hyphen hyphen subscribe events to 4443 port, and double slash missing here. So TCP colon //. Perfect. So that's all you need to do. And now when you hit an enter, now it will create a node and also register this node to the hub which is sitting in another machine on this IP address, and it will ping that 4442 port, 4443 port. Okay, let's see. Awesome. Looks like sockets are created. You can see that it is reporting everything correctly here. Cool. So now let's come back to our hub, and when you refresh, here you go, there is another node added. This node is now coming from different physical system, right? You can see that IP address is also different. That way you can conclude that this belongs to another position. And if you observe, by looking at these two nodes, can you guess which is the node coming from another physical machine? This one. How? See, there is no Firefox here. We don't have Firefox driver installed, right? Specifically in that folder. As it could not find Firefox driver, it decided that this node do not have ability to run on Firefox. Okay, so because we didn't add Gecko driver there. So this is your local system where hub and node both are there. This is the another physical address which we are talking through that team viewer. We connected to that machine and we made that work. Cool. So we have successfully set up two nodes. This is enough for us to start testing. So in the next lecture, let's create one small project, create TestNG tests and run them parallelly and see magic of distributing your tests to different machines. Okay, welcome back. Thank you. Just to recap, so in the last lecture, we have successfully created a grid infrastructure setup. So we created a hub which will automatically start session map, distributor, router, right? So these three are already started when you have created a hub, right? So similarly, we created two nodes. One node we started in the local system and one node we created in another physical machine. So these are the two nodes and we have registered these two nodes to our hub, right? So we have given the enough commands to register with subscribe events and publish events. So one of the node is installed in the same machine where hub is there. So that's why there we don't need to give any publish and subscribe events. We directly just started the node. Okay, so good. So we have completed this setup. The only thing remaining now is a client. Here is where you write your actual Selenium code now and send your requests, and these will take care. Okay, so now you might be wondered like, where can I see distributor, where can I see router and session map? See, all that is taken care internally. Okay, so once you started as a hub which comes with all these components, so if you want to debug one by one, you cannot see that from the outside when you have chosen hub node role, right? So there is another way called distributed system, right? If you choose that way of setting up your infrastructure, then you can see the logs of all these router, session map and distributor. But that internal details are not really required to run this architecture. Okay, so what all we need is to distribute our tests in different machines, and we are good with that. We have completed our setup. So now let's solve the client process by going to Eclipse, creating one small project and create multiple tests and see how we can route our client information to router. And once it reaches router will take care of all distributing, right? So now I'll go back to Eclipse. I'll create one small Java project here. New project, Java project. So let's call it as a Selenium Grid. Next, finish. Don't create. No. So one Java project is created. Now let's add Selenium jars into this project. So I'm not going with a Maven project. So I'll just simply add the jar into project Java build path, right? So here under the class path, add external jars, and I already have Selenium jar which I downloaded. So I'm just going to use that jar. That's it. Apply and close. this one single jar will help us to run tests, right? So here I'll create one new class and let's call it as Google test. Awesome. So here we are using testng annotation. So @test, and I'll start writing my code. So public void, let's call this method as homepage check. Okay, homepage check. I'll write one simple Selenium program. That's it. I'm not going in deep dive and writing any end-to-end automation here. So our only goal is to see how it is running in different machines, right? So we can use small validations. Let's add testng library. All right. So the first step, now generally, let's say if you want to run in a Chrome driver, you will start like this, right? Driver equals to new Chrome driver. But here problem is, if you start like this, your hub will never know that this test is getting executed. Why? See, where are you giving details to actually reach out your hub? See, now if you see the architecture, your client has to first reach your hub. So here it is first reaching router, which is part of hub. So when I say hub, the whole three components constitutes a hub. So we as a client, our Selenium, we are reaching the hub asking to solve our request by running the program, right? So if you just start saying like this, WebDriver, Chrome driver, you are sending the request to your Chrome browser to run, but you are not sending request to your hub. So if whenever you are running using Selenium Grid, there is a different way of initializing your driver. So you have to use a class called new remote web driver. This is how you have to initialize your driver. So move your cursor and here you will have one package. So name itself tells you that you can execute your tests remotely in remote machines if you invoke and create your driver object as a remote WebDriver class. Now, so this remote WebDriver class take two arguments. One argument is the information where your hub is listening. Okay, so that's where you have to send this request, right? So you have to make a request to your router. A router is sitting on which? So that means where is your hub listening? Your hub is actually listening at this one, starting Selenium hub at this IP address colon 4444. This is the port number where your hub is there, right? So now you have to give that URL here, but you cannot just pass URL directly as a string. You have to wrap your URL in one class like this. New, the class name is URL. In this class argument, you can pass the actual URL where you want to send your request. Okay, if you directly send it as a string like this, this class still treats this URL as a string. But to tell this class that we are sending a URL, in Java there is a class called URL. And if you wrap your string in that URL class, then this recognizes is one of the URL in your browser to execute, right? So move your cursor and import this URL class. This is coming from java.net package. Great. So the first argument you have successfully provided in the remote WebDriver. So what else is missing? So your test know where to report asking to execute. So whenever you run your test, it automatically reaches the hub. So that means client make a request to router and then it will take it from there. But when it reaches distributor, for first time, it still did not have the enough information like on what browser it has to execute or on what operating system it has to execute. So earlier, without Grid, we used to create Chrome driver here so that your test knows that it has to invoke Chrome browser. But now this is a generic, right? And we still did not give the details like what operating system browser it has to run. Okay, you might still write the code like invoke Google homepage, everything. That's fine. But it has to have some capabilities, right? Like browser execution which version, everything. So for that, when you are dealing with this remote WebDriver class, you have to create one more class called decide capabilities. Okay, let me create that class. So basically from this class object, you're gonna define all the capabilities, like what browser you want to execute, everything. And finally that object you are going to send as a second argument to your remote WebDriver class. So this way your test knows in what browser it has to run. Okay, so it will simply give all the details to the router. So as it is the first call, router sends this information to distributor, and distributor then check this caps object and see what is the required browser I want to know, and it will distribute to the its related node. Okay, so now here you can set your browser with caps dot set browser. Okay, you can see that set browser name here, where you can provide the information on what browser you want to execute. You can also give the information like on what platform you can execute. Let's say if you want to execute this in the Windows platform dot, and when you type W, you will get all the options. So if you want to run Windows 10, 8 or anywhere. Okay, so you set all your capabilities, and then once it reaches the router, this router guy, as is the first session, it will simply send to distributor to figure out. Distributor will check what operating system they are asking. If it is Windows, it will immediately check how many nodes I have. Is there any node which have Windows platform? Okay, if let's say one is Windows, one is Mac, so that test what you are asking to run on Windows, that will go to Windows node. If you specifically mention Mac and one of its node is Mac, then it will delegate access to the node which is having a Mac operating system. So like that, this capability object is key. So this is where we decide to what local physical machine we want to assign running the test. Okay, so this is only for first time. Once the session is initiated, now let's say in this case distributor checked this code and you are asking to run in Chrome. So it found a node which have a Chrome browser, so it delegated to run in that Chrome node physical machine. At the same time, what distributor does is it creates entry in the session map. So basically what is the session it got, that session ID, and to which physical machine it allocated that IP address. So next step, when you make a driver.getgoogle.com, as this is coming from the same session, so this router guy first will check in the session map if there is already existing session. Yes, it's there. And then what is the IP address of the node? It will simply find out the node and it will give the request directly to that node without disturbing the distributor. Okay, that's the concept. That's how internally it runs. So to make this happen, you need to send two important arguments here. One is about where is your hub is sitting as a first argument, and what are the capabilities you need to send to distributor to decide which physical address it has to execute. I mean, which node or physical machine. These words can be interchanged here, right? So you can also set some advanced capabilities like this, caps.set capability, and here you can mention what is your capability type. Let me show you. So move your cursor and change to capability type, and here when you say dot, you will get a lot of other options. Like in Chrome, if you want to accept SSL certifications, then accept it and set it to true, so that if it find any SSL certifications, by default it just accept it. So like that, you can set full capabilities on how you want your browser to behave. You can go over it. You can element scroll behavior, profiling capability, touch screen. So a lot of capability options. If you want to set any proxy to your browser before invocation, you can set that as well. Okay, so you can also set your browser from here. See, you already did this. This is one way. They just directly provided one method to simply set the browser, or you can come here and you can set here also. This is another way to do that. Okay, If you do in this way, you have a lot of other options also to set. But in our case, if your goal is to simply decide which platform and browser, which is most of times, then you can use this simple step and you can ignore this. I'm just giving you for your knowledge purpose. Later, if you want to have additional capabilities, use this syntax, just press dot and set the capabilities. And finally, after you set all these capabilities, send this caps object here and that will take care. All right. So I'll write one simple step where we go to google.com homepage and let's say I want to enter in that edit box. By default, Google homepage edit box will have one locator called name. If you want, you can check. There will be one attribute with name and that attribute is Q. That's there from ages. So we will simply enter Rahul Shetty and that's it. And we will grab the title of the page and print it in the output. Okay. So this is a simple step I want to do. Right. So it will go to Google homepage, get the title, enter some information in the edit box, and then we will close the browser. Right. So this is one test. So similarly, I'll create another test here. Copy and in the same source folder, I'll paste it. And here I will ask to go to Rahul Shetty Academy website. So RSA test. So in this case, what I will do, I'll set browser to Firefox. So I'm asking to run this test on Firefox, right? So don't worry how it handles. Once it reaches router, whenever your RSA test session ID reaches the router, that will send it to distributor and distributor will open this capability object. If it found Firefox there, then it will check which node have Firefox and it will assign to it, right? So in our case, so one of the machine do not have Firefox. Okay. See, this is our another physical machine which we connected through TeamViewer, right? This do not have Firefox. So that means the test RSA test will never run in this another node what you have installed remotely. We can see that output later. And here I will just hit my website, and my website do not have any name attribute Q. So let's just get the title and close it. That's it. So I created two tests here. So here, maybe instead of using set browser name like this, I can show something like this. So I'm showing you different ways. In first test, I directly use that set browser name. And here I'm using capability type dot, and this is another way of writing syntax. Okay, so one test on Chrome, one test on Firefox, two simple tests we have written. And now let's convert this project to testng so that you can run them parallelly at a time. So right click testng, convert to testng, and here, so these two are two different classes, right? So parallel mode, yes, we want to run classes. So that means two classes, Google test and RSA test, we want to trigger them parallelly. So I selected that, and when I click on next and finish, it will create one XML file for me by default. So that's the magic. If you simply right click testng and convert to testng, right? Go to this XML file, go to source tab, and this is your file. So two classes are there. Okay, remove this dot because we don't have any package here. So this is a default package. So these are the two classes and we are asking them to run parallelly. Cool. So in the next lecture, let's trigger this testng XML file and see what's happening and how Grid is playing the role. Now let's see what happens when I run this XML file. So this XML file will trigger two classes, RSA test and Google test, right? So this test will be invoked, and at the same time, this test will be invoked. But we are asking them to run parallelly. So that means two sessions will start parallelly, but both these sessions will report to this IP address. On this IP address, your hub is ready, right? This is listening. So those two requests will reach this router, as these are the initial requests So router cannot get that information from session map to send it to the nodes to execute. So it will give it to the distributor. Now distributor will open this capability object and it will see that, okay, one of the session is requesting to run on Chrome. So it will just see what Chrome I have in the two different node physical machines. And it will also see the another request. This request is asked in Firefox. Okay. So now distributor will decide that, okay, this node machine do not have Firefox. So it will assign Chrome related test to this external node machine and the Firefox to this node. Okay. This node is our local system only. So that means execution will start in your this local system. Two nodes what we installed, what are those? One is your local system only we started where hub is there, and one is externally through TeamViewer we started, right? I am expecting that this Chrome test will be picked by the external physical machine because that we don't have Firefox, and RSA test will run in my local machine. That is how it should happen. Okay, so I'll open the TeamViewer. We are ready here just to see if it is opening or not. There is my Eclipse. Here it is. So right click, run testng suite, save and launch. So where is the TeamViewer? Let's see. Here you go. In TeamViewer, Chrome started, and you can see it's already done. In your local system, Firefox started. Awesome. I hope you saw that magic. Let's run again. I'm curious. 2 run, 2 passes, no failures, and you can see that browser name Google and Rahul Shetty Academy titles are printed. As expected, Firefox invoked in your local system, Chrome invoked in your TeamViewer other physical machine. Let's see. Run as testng suite. Yeah, TeamViewer Chrome, and back in your local system Firefox is running. You can see that. Awesome. So that's how you can distribute your tests. Cool, right? And do remember that it is not necessary that your client, which is your Eclipse, where you have installed and triggering this test, it's not necessary that it should be in your hub machine. Okay, because of infrastructure limitations in the recording, I am showing you that hub and the client where we are running our test in the same machine. But at real time, all the hub process can be in one machine, your Eclipse Java code can be in another machine, and your nodes can be again another physical machines. Okay, see, no matter from which machine you are running your test, ultimately you are asking to reach this hub IP address, right? So it doesn't matter if the hub and your actual client is in same machine or different machine. You are however making and sending that your test request to your hub with this address, right? So make sure this address of the hub is correct. So if this is correct, then this Eclipse code you can write from any other machine. So that's how you do in real time. So what does people do in big projects is like, they create multiple nodes. They'll bring at least 5 to 6 physical machines. In every physical machine, they will go and set up the node just like how we did now through TeamViewer. Yeah, so here we configured the node, right? Just like that, you just need to ask your management, give me 4 or 5 node machines because I want to run my Selenium test parallelly in multiple machines. So that way we will get faster feedback. Okay, if you run them sequence in one machine, it will take 2-3 hours to get result. But if you distribute them running in 5 to 10 machines, just imagine the results will be out in 10 minutes. So that's how you need to talk to your management. Get at least 5 different servers, 5 different physical servers, log into them and set up node in all those machines just like how I did here, and then set up hub in one system. Maybe you can do in your local system also, and just trigger. That's it. Just create all the desired capabilities and route them to your main hub and bring all tests parallelly in your testng and trigger it from here. That's it. So all the tests will run parallelly in all different physical machines, and it will finally report to your local machine output like this. So that's the beauty of Selenium Grid. Okay, so I didn't focus much on coding here, guys. So no matter you write 2 lines of code or 10 lines of code, overall this test will execute there based upon the how much code you have. Okay, hope this help, and you can download the document and the repository from this next lecture. Okay, thank you.